I'm going to start studying for my DAA exams, and I will watch algorithm in Abdul Waris's video.
Hello friends, I'm going to start a course on algorithms. Algorithm as a subject. Algorithm is a common subject for computer science engineering students. Most of the universities offer this course as a part of syllabus. And this is a very core subject and very important subject. And students face some difficulties in some of the topics in this one. They could not understand them very clearly. So here I'm going to make the subject more and more simple so that you can easily understand and even you can practice that and also remember it easily. The importance of the subject is that apart from theoretical examination, it is also important for competitive exams. And even programming contests, most of them are designed from this subject only. If any programming challenge is there, then mostly they become the questions from this subject. So this is one of the challenging subject for the student because they get a chance to solve different type of problems and they get the strategy or approach for solving the problem. So some students fail to understand it properly, so they could not get the approach for or the strategy for solving the problems. And they feel that they are lacking in the logic development or strategic development of a program. So I'll be covering in depth each and everything, right from the basics to the depth. Right, so that you will be able to answer any type of question from this one. I will cover the topic such that just you look at the question, you can get the answer. That I guarantee you. Right? So the thing is, I'll cover those points which are useful for solving the questions. Some job interviews or even for any other exam or some entrance exams like GATE exam, the questions are framed from algorithms also. This is also one of the key subject there. So you will be able to answer any type of question from there. Now to watch the lectures in the order, I'll be giving the numbers for each topic so that you follow that order, you follow the sequence because I may be breaking the major topic into smaller topics. And one more important thing is, your feedback is very important for me because already I have prepared few videos. Using presentations and other tools, but now I'm giving a lecture on whiteboard, so maybe I'm new for the video quality and audio quality on these things. So technically once I get set up, so I need your feedback so I can make my videos more and more better. So your feedback is important for me to know how the video quality and audio quality you are getting it on your devices, because I have checked on different devices and I found that the results are different. So what devices you are using, what I should improve, voice or what, so I need your feedback. Let us start with just introduction. What is an algorithm? What is an algorithm? Why it is written? When it is written? Who will write it? Let us get the answers for these. See, algorithm as a definition, it's a common definition, everybody knows that. It's a step-by-step procedure for solving a computational problem. Yes, it is a step-by-step procedure for solving a computational problem. Then what is a program? Program is also a step-by-step procedure for solving a problem. Then what is the difference between program and algorithm? So by comparing program and algorithm, I can make you understand the importance of algorithm, meaning of algorithm. Let's take it. Here's an algorithm and here's a program. Let's see the first difference. If you know the software development lifecycle, the phases of developing a software project. In the phases of development of software project, there are two important phases: design phase and the implementation phase. Now, if you are not aware of it, let me tell you. Whatever you want to manufacture or construct something by engineering procedures, then first step, one of the important steps is design. First, you do designing. Make your design perfect and thorough so that you can understand what you are going to construct, what you are going to develop, and when you are sure what you are going to develop, then you start the development. You can't develop anything, you cannot construct anything on trial and error basis. Like you constructed something, again, no, it's wrong, destroy, and again create a new one. So no. But it is easy in software engineering. A software engineer can write some program and change the mind, delete the program, and again start writing the program. So that's why we cannot get the feel that we have wasted so much amount of time in writing so useless program. So the point is, first you design and then you write the program. So at the design time, what do you use? So you're not writing a program, then what do you write? So that same program, we write it in simple English-like statements that are easy to understand without using proper syntax, and we will not writing on machine, that is on computer, we will be writing on paper. Or even if you're using a machine also, then you will not writing in some language, you can be writing in MS Word or Notepad-like application. So just you are getting familiar how your program going to work. So that's the thing about an algorithm. So algorithms are written at design time. And when the programs are written, they are written at implementation time. Design time and implementation time. So first you make a design, what your procedure is going to do, what your software is going to do, come up with some design, and that design you convert into a program. Then what do you call the person who do designing? Whether the programmer does that? Yes, if programmer is capable of doing that, he can do it. Otherwise, the person who will do this one should have the domain knowledge, the problems knowledge about the problem and its solution. He can give a solution, the one who understands the problem and has the domain knowledge. Suppose you are developing a software or an algorithm or a program for account, then accountant can understand accounting better. Or if you are writing an application or developing an application for hospital, then doctors or the administrative staff of a hospital can understand the system better than a programmer. So mostly the one who is having a knowledge about the domain for which the application is being developed, they can write out the algorithm. So the person who writes should have domain knowledge. Who will write the program? Programmer. So programmers can also have domain knowledge. They can also have domain knowledge that he is acting as a designer. And here he is acting as a programmer. Next, what is the language used for writing algorithm? You can use any language. Any language means English-like language, or you can use some mathematical notations. If you're writing English-like language, it will be like writing paras or summary. But don't write. If you want, you can use mathematical notations also. It's better if you use mathematical notations. So any language can be used, any language means English language or some mathematical notations can be used as long as it is understandable by those people who are using it. Like if a designer has written an algorithm, then the programmer will be writing the program for it. So designers should understand and also programmers should understand that one. Right? So the team of programmers who are working on that project should be able to understand it. Then this is written only using programming language. Like C, C++, Java, Python. Right? So you can use different languages for developing a program. The next, one more important thing here is, when you write an algorithm, it's going to be hardware and software, means operating system independent. It's not dependent on hardware, what machine you are going to use, what's the configuration of the machine, and what's the operating system, either Linux operating system or Windows operating system. We don't bother about it. But when you write a program, it is dependent on hardware and operating system. So when you write a program, you have to select some hardware on which you are going to run, and also you have to select some operating system. You may be doing it for Linux or you may be doing it for Windows. So the method will be different and the environments are different. So this is important. The next, after writing an algorithm, we analyze an algorithm. Means we will study the algorithm to find out are we achieving the results perfectly or not, and our algorithm is efficient or not in terms of time and space. We will see what is the theme and analysis. So we will analyze an algorithm. What do we do with the program? So we don't have to study the program. Already the program is there. Just run it and check it. So we do testing of the programs. That's it. These are a few differences between algorithm and program. These differences will help you understand what are algorithms. Alright? Now, one more thing I will tell you. The syntax of the language that we use, any language can be used, but who actually write algorithms and who use them and who write the programs? So programmers who are coming from university graduates, mostly university graduate knows at least C language. So nowadays, mostly in the name of algorithm, we write C language program. So the benefit is that the advantage is that everybody knows C language now. So instead of writing some other language to confuse, we can use C language only so that everybody can understand. So even at a school level, C language is being taught, so everybody is familiar with C language. So I will be using C language syntax for writing algorithms. Let's talk about priori analysis and post-priori testing. These are the two terms that are used for algorithms and programs. Priori analysis is done over the algorithm. So priori analysis means we will do the analysis of an algorithm by studying it into greater detail, knowing how it is working, and we get some results. The result of analysis there. What's that? We may find out the time and the space consumed by an algorithm. The result of analysis. And testing is done on the program. So we run and execute the program and check it. So we will know the watch time it is taking, how many seconds, milliseconds it is taking, and also the amount of memory it is consuming in terms of bytes. So this is priori analysis is done on algorithm, and the post-priori testing is done on programs. Now when priori analysis is done over an algorithm, we know that algorithms are not written in a particular language. So they are language independent, and also they are hardware independent. They are not meant for particular hardware. But whereas a program, we write a program that is hardware specific, as well as language specific, and as well as operating system specific, environment specific also. So they are dependent on the hardware as well as the programming language used. And here, the result of this one is how we get the time and the space. We don't get watch time, 3 minutes, 10 minutes, 5 seconds, or milliseconds. No, we will get the time function and we get the space function. Now let's video characteristics of algorithm. What are the characteristics? What are the properties of an algorithm? So let us check. First one, algorithm must take some input. So some algorithm may not take any input also, but algorithm can take 0 or more input. They can take 0 or more input. The next, output. Algorithm must generate at least one output. Otherwise, it's no use of writing algorithm. It must generate some result. See, imagine them like function, C language function. Like when you call a function may not take any parameters also, but function returns something. If it's not returning, we say void. But it does something definitely. If it is returning, it should not be a return type, but the function gives some result definitely. That's what is the output. At least one output. Then, definiteness. Every statement should be unambiguous and it should have a single and exact meaning. You cannot write any statement which cannot be understood or which cannot be solved. Like if we human cannot solve it, we can't ask our computers to solve that one. So every statement that you're writing should be definite. That's clear. So definiteness. You cannot use the value, for example, I tell you. You cannot use the value, let's suppose root minus 1. It's unknown value. Unknown value. So we say it has imaginary number. So you cannot treat it as a real number in the algorithm. Right? This is an example I'm giving you. So every statement must give clear meaning, only one meaning. That's all. Then let's just finiteness. Algorithm is just like a function, as I said. A function will have some limited set of steps and it will stop and returns the result. So same way, algorithm must terminate at some point. Whether it may be having 10 statements or maybe having 10,000 statements, but it must have finite set of statements. The duration of algorithm must be finite. Definitely you will stop writing after some statements, you may stop. But the meaning here is that there are some programs which runs continuously unless and until you stop them. Like example, database server. Oracle server, you start. And if you leave the machine as it is and don't stop it, then Oracle server will keep on running. SQL server, it will keep on running. It's like a service. Web server, keep on running. So it's not a service, it's an algorithm, it's a procedure. So it must stop. Then effectiveness. Now, this is simple. You should not write unnecessary statements in an algorithm. Whatever the statement you write, the objective is that it should do something, serve some purpose in the procedure, in the steps of an algorithm. Don't write unnecessary statements. See, algorithm is like a procedure. So there are many procedures. Like a chemistry experiment done by the students in the laboratory is a procedure. And physics experiment done by the students in the laboratory is also a procedure. Or if you take a procedure for preparing a dish, cooking a dish, that is a recipe, that's also a procedure. And every procedure, the names I have given you, examples I have given you, every procedure needs some input. The chemical experiment needs some chemicals and apparatus, and physics experiment needs instruments, and the recipe needs some ingredients. Then, objective of that procedure is to give some result. You are cooking and cooking, but no dish is prepared. Nothing like that. You are doing some experiment, but no solution is obtained in chemistry experiment. No, there must be some solution. So definitely there must be some solution, at least one solution. Definiteness. All the steps that you are doing are known steps only. You are not doing anything magical. Right? Known steps you are performing. Every step that you're doing here is known step, and nothing is magical, right? Only known steps you are performing. And finiteness. If you're preparing a dish, you will stop at some point and the dish is ready. If you're doing a chemical experiment, you will stop at some point and the solution is ready, definitely. And effectiveness. You will not do anything unnecessary while doing this procedure. Like you are boiling some chemical, but you're not using it in the experiment. It's not mixed with the solution. You are cutting some vegetables in the recipe, but that is not used in the dish. So there's unnecessary things are not done in the procedure. So here also in the algorithm, you should not have any unnecessary statements. Next, let us see how to write an algorithm. Here already I have written an algorithm for swapping two numbers or two elements. See, I have used C language like syntax only. Only thing I have done is here I wrote algorithm to show that, okay, I'm writing an algorithm, it's not a program. Here, if I compare with the C program, here I have not written the data type of parameters. Yes, data types we don't decide at algorithm time. When we write a program, then we decide what data types are required. And here, even I don't have a temporary variable declaration. Declaration is not there. Directly it is used. It's understood. Unless you declare in the program, you cannot use it. But in algorithm, we don't bother about those minor things that are related to language. This is more like C. Now, if you want to write in a different way, you can say this as begin and this as end. Instead of flower brackets, you can also say begin and end. Next, you can use this symbol also for assignment. Actually, this is an assignment symbol that was used in some old languages, like Pascal language. So you can use that one. Or else, you can use this symbol for showing that this value is stored in this one. So now it's up to you how you want to write it. I hope whatever I wrote you have understood it. So same way, whatever you write, I should be able to understand it. At least you should be able to understand it. Or the people who are involved in the project should be able to understand it. Who are using it should be able to understand it. Right? So you can use any syntax. There is no fixed syntax for any algorithm. Let's see how to analyze an algorithm. What is the criteria on which we analyze an algorithm? So the first criteria is time. See, the algorithms are the procedures for solving problem. Whether you do it manually using pen and paper or you make a program and let your machines do it. Whatever the method may be, how much time it is taking. If the procedure is very lengthy and time consuming, or whether the procedure is very fast and quickly you can get the results. So that is one of the important criteria on which you have to analyze. If you are devising a procedure or an algorithm, then it should be time efficient, means it must be faster. So after writing the algorithms, we analyze how much time it is taking. So that time, what we get is in the form of a function. We get a function, time function. We not get the watch time. Already I have shown you. You will get the function, time function. Now, next is space. As the algorithm is going to be converted to a program and is going to run on the machine, then we need to know how much memory space it will consume. So that is the second criteria on which we will analyze an algorithm. So these are the two major criteria on which the algorithms are analyzed. And furthermore, if you have any other criteria or any other factors you want to consider, you can consider them. Like, nowadays, every application is either internet-based, web-based, or say cloud-based. So data transfer or network consumption is also an important criteria. How much data is going to be transferred? See, the algorithm or a procedure that you're writing, if it's necessarily transferring large size data, or it can be reduced or compressed, whatever it is. So that is one more important criteria, that is how much data transfer is done. And nowadays, most of the devices are handheld instead of PCs. We are using palm tops and laptops and tablets. Then power consumption is also a criteria. How much power it is consuming? And one more criteria is, if you are developing an algorithm for device drivers or system level programming, if you are developing some algorithm you're writing, then you may also need to know how much CPU registers it is consuming. So CPU will also have some memory called as registers. How many registers it is consuming? That's also one of the worrying factor when you are designing an algorithm or writing a program. So these are a few criteria I have listed, and it depends on your requirement, it depends on your project, right? What are the more criteria you need to analyze? Now let's see, I have taken one example to show you how we analyze an algorithm. So for analysis purpose, we need to know the time. So first we do time analysis, then we do space analysis. Now time means how much time this will take. It's not the watch time, then how to assume? Now we say that every statement in an algorithm takes 1 minute of time. Every single statement in an algorithm takes 1 unit of time. If suppose the algorithm is calling another algorithm, is using another procedure, then you have to analyze that also in detail. So simple means just statements, direct statements. It's not a nested statement, right? So single statement, each statement takes 1 minute of time. So here I assume it takes 1 minute of time, 1 minute of time, 1. So total time is 3. So the time function f of n is 3. Here we got a constant value because I have taken a very simple algorithm and the answer is 3. That is some constant value, right? 3 or 30, whatever it is, it's constant value, fixed value we got. So that's the time function. It is not in terms of n, just we got a constant value. Now here, whatever the complexity in the statement may be, how lengthy the statement will be, we say that it takes 1 minute of time. Let us assume, instead of this statement, I have some statement saying x assign 5 into a plus 6 into b. If this is the statement written in an algorithm, then for this also we say it takes 1 minute of time. But really, if you see, when you convert it to a program and finally when it gets converted into machine code, then how many statements it will have? For each multiplication, 2 statements. Then for addition, 1 statement, the assignment, 1 statement. So total 4 statements will be there. But we don't want to go into that much detail. We don't want to see how it's going to get converted to machine code. But simply we analyze and say each statement takes 1 minute of time. Now suppose, if you want to go into detailed analysis like this, you can go into detail. You can imagine up to the level of the machine code that's going to be generated. It is just like, suppose you want to travel to your friend's house in a car. You don't have to think and you don't have to plan and analyze. Simply you can take your car or your bike, your vehicle, and you can just start and reach his place. Right? It's simple. If you want to land on Mars, then simply you cannot take a satellite, so simply you cannot take a rocket and launch it and reach there. It's not easy. So you have to analyze and design and make a complete plan so that your mission is successful. So that's it. Here you need to go into each and every minor detail you have to take care of it. So it depends on your requirement. So if you want to analyze into greater detail, then do it. From some point of view, we will be doing it at basic level. right? At a very shallow level, this brief analysis will not go into much detail, but much detailed analysis can also be done. Next is space analysis. What are the variables used here? For a space, I'll write down the variables. A is one parameter, B is also a parameter, and temp is the local variable used. So total, how many variables? 1, 2, and 3. So there are 3 variables used. So the space is constant again. It is just 3. I got the answer as 3. So again, it's also constant. So usually we represent them as order of 1. Constant is order of 1. And that's also order of 1. Means it is constant. 1 because it's constant. If it is 3 also we write 1. If it is 3000 also we write 1, saying that it is constant, the value is constant. So this is how each statement is taken as 1 unit of time, and each variable is taken as 1 word. So these are 3 words. Why we are saying words there, not bytes? We don't know. When we convert it to a program, it may be an integer type or float type or double type that we don't know. So that's why we say it is taking words. Now this is frequency count method. We will take some algorithms and find out how this method is useful for finding the time complexity of algorithms. This algorithm is for finding sum of all the elements in an array. Here is an array. Assume that it is an array of some elements. I have taken an array of size 5 with some elements in it. So what is n? N is 5. So A is this array and n is 5. So what this algorithm is doing, it is finding the sum of all the elements in an array. Let us analyze the time taken by this algorithm. So how do we do that? By using frequency count method. So the time taken by an algorithm can be known by assigning 1 unit of time for each statement. And if any statement is repeating for some number of times, the frequency of statement, the frequency of execution of that statement will calculate and we find the time taken by that algorithm. So here we have some statement, this is a statement which is repeating for some number of times. So we will find out its frequency and that will give us the time taken by this algorithm. So let's see. So this is a simple statement, so this takes 1 unit of time. And as this is a C language code followed by Arabic, this is a C language code. In this one, we know this will execute for 1 time. And this will repeat for n times. But this condition will be checked for n plus 1 time. How? When n is 5, then first time I will be 0. 0 is less than n. When I is 1, 1 is less than n. I is 2, 2 is less than n. I is 3, 3 is also less than n. 4 is also less than n. 5 is not less than n, so it will stop. So I was initially already 0. So how many times I has changed? 5 times. Then how many times this condition is checked? 1, 2, 3, 4, 5, 6 times. 5 plus 1. 4 times it was true, and 5th time it was false. When it became 5, it was false, so it has stopped. So this is executing for n plus 1 times. So we say that if you sum up this is 2n plus 2, but we write n plus 1. So it means we are bothered about this one only. Right? We are bothered about this one. We don't want to write about those things. Usually it is written n plus 1 only, but if you observe it carefully, it is 2n plus 2. But we don't want to write the time taken by these two. Right? As I said, we will be doing it briefly. Then, whatever the statement is there inside this loop, as this is repeating for n times, this statement will also repeat for n times. So this is n times. So now we can understand that whatever is written in a loop, like this type of loop, the statement will execute for n times. And the loop itself, if you take, it will execute for n plus 1 times. Then the last statement, it will execute for 1 time. Then what's the time function? F of n is 2n plus 1, 2, 3. That's it. That's the time function. Now, what is the degree of that polynomial? It is a degree 1. It is just n. So we say order of n. I'm calling it as order of. I'm not saying big O or theta. We will learn it in some other video. Now, for now, I will say order of n. Base complexity. See what are the variables used here? A is used, n, s, and I. A, n, s, I. The size of A is n words, and all these are just one word. So total is how much? N plus 3. So the space complexity is S of n is n plus 3. Now this polynomial is also degree n. So we say auto space complexity we got it as order of n, and the time complexity is also order of n. Now next algorithm is for finding the sum of two matrices. A and B are square matrices of dimension n cross n, n cross n. For example, it is 3 cross 3, then these are matrices or two-dimensional arrays of size 3 by 3. Dimensions are 3 by 3, assume that. So n by n, they are n by n. Now here I have an algorithm for finding the sum of two matrices. Let us find out the time complexity for this one. Follow, already know, this will take n plus 1 time. Now whatever is there inside this loop will execute for n times. This is n, this is also n. Two lines are there, two statements are there, each taking n. Then what is this? Again this is the loop. So for this also, n plus 1. Then again, whatever is there inside this one will execute for n times. That's it. Now what is the time taken by this one? F of n is n square, 2n square plus n and n. So 2n plus 1. This is the time function for this algorithm. What is the degree? Highest degree? 2. So we don't write degree, we write n square. Order of n square. So we are writing the degree. We are not saying that it's equal to this one. We are saying that degree of this polynomial is n square. That's all. This is the time complexity. Let us take space complexity. What are the variables it is having? A, B, C. A, B, and C. N, I, J. N, I, J. What are A, B, C? They are matrices. Two-dimensional arrays. N cross n. N square. N square. N square. What are N, I, J? They are scalar variables. Simple variables. One word, one word, one word. So space function is 3n square plus 3. Then what is the degree? N square. So this is also n square. Space complexity is also n square. So the time and the space complexity of this algorithm is n square. How to find the time complexity? I have shown it here. How to find the space complexity? I have shown it here. So for few algorithms I may be showing. For any algorithm you can find out this one by following this approach. Next algorithm is multiplication of two matrices. You can see that there are three loops nested, one inside another, one inside another. Let us find out the time. On this side I will write. This will be a little far away. So this side I will write so you can see them. This is n plus 1. Whatever is there inside will execute for n times. Every statement n times. Then again this is a loop. So this is n plus 1. Whatever is there inside will execute for n times. So into n and into n. Then again there's a loop. So this is n plus 1 times. Whatever is there inside will execute for n times again. So as this statement is inside all three loops, so this is going to execute for n cube times. This is inside just these two loops and these two loops. So this is executing for n square. And these are loops themselves. So that's n plus 1 and this is n square and this is n cube. If you finally write down the time function, f of n will be equals to, see, n cube and one more n cube, 2n cube plus this is n square and this n square and this one more n square. So 3n square plus this is 1n and 2n. So 2n plus 1. That's it. Now we got the degree of a polynomial as cube. So the time function is order of n cube. It's order of n cube. Let us see space for this one, space complexity for this one. The variables is having A, B and C. Yes, A, B and C. N, I, J, K. N, I, J and K. So this is a matrix. So n square, n square, n square. And all these are 1, 1, 1. So this is space is 3n square plus 4. So this is order of n square. Time is order of n cube. Space is order of n square. You can have a look at this whole thing. So that's it. So I have shown you three different algorithms taking different amount of time. One was order of n, and n square, and n cube. Next video you can watch the different types of algorithms and also the method how to analyze them. Welcome back. I will take few pieces of code and show you how to analyze them. How to find out the time complexity for them. This is a simple loop. I'm not writing a complete algorithm. I have just written a piece of code in which one statement is there. Now we are already familiar with this one. We know that this will execute for n plus 1 time and this will execute for n time. We don't want this time because anyway when we are writing order of, we are writing a degree. So this will not affect the degree at all. So it will be the same only. So just you need to know the statement how many times it's executing. So that's it. So this is order of n. You can avoid this one. Skip this one. Next, if suppose this loop is starting from n and the condition is greater than 1 or 0 and this is getting subtracted. So this loop is decrementing. Then also, this statement will execute for n times and sort of n. Whether you go from 1 to 10, n steps, or come from 10 to 1, then also 10 steps. So you go from 1 to 10 or 10 to 1, same number of steps. So that's how n to 0 it is. So it's also order of n. If this is starting from 1 and condition is less than n and I is being incremented by 2, so this statement does not repeat for n times but half of the n times, n by 2. If it is n by 2 also, if I say function is n by 2, what is the degree of polynomial? N only. So it's order of n again. So in this case also it's order of n. Even if it is incrementing by 20, then this is 20. Degree of a polynomial is n, so this is also order of n. So n by anything, just whatever the number of times it is incrementing, the time will be same only. Next, we are already familiar with this one. These are two loops, nested loop, one inside another, and this we know this will execute for n times. So this is also n times and this is also n times. Actually it's n plus 1. But what about this one? Again this will repeat for n plus 1 times and this will repeat for n times. And this is order of n square. The next is again nested for loop. This looks similar to the previous one, but not. See, I takes value 0, I less than n, but j takes value j less than I. So here's the difference. So let us analyze this by tracing this one and find out how much time it is taking. So for this, I will take I value and j value and trace them. Let us start. Initially I is 0, when I is 0, j starts from 0 and 0 less than 0, no, it will not execute for any number of times. So here I have to find out how many times this statement is executed. So number of times. So it will not execute at all, so 0 times. Then this loop ends again, I plus plus, I becomes 1, I is less than n, suppose it's enters inside. Then again this loop, 0, 0 is less than 9, yes, for 0 it will execute. Then j plus plus, j is 1, 1 is not less than 9, so for 1 it will not execute. So how many times it has executed? 1 time. Then goes up again, I plus plus, I becomes 2, then j will execute for 0, 1, and when it becomes 2 it will stop. So this will repeat for 2 times. And when I is 3, j will take 0, 1, 2 and 3, so this will repeat for 3 times. And this process continues. See, when I was 0, it was never executed. When I was 1, it was executed for 1 time. This is statement. I was 2, it was executed for 2 times, 3 times, so on. So on, up to what? N. So total, when it is n, right, how many times this will execute? N times. When I was 3, so 3 times. So if it is reaching till n, actually it is less than n, but let us say n is reaching till n, so it will execute for 10 times. So total, how many times it is executed? This one. Right? So I'm assuming that it is going till n, though it is not till n, it is less than n. How much that is? 1 plus 2 plus 3 plus goes on to n. This is nothing but n into n plus 1 by 2. What is the degree of this one? F of n is n square plus 1 by 2 degrees square. So order of n square. So the time complexity is order of n square. Though this is not similar to the previous one, but if you analyze, the answer is coming to n square only. The degree of a polynomial is n square only. Next code is, here p is initialized to 0 and this loop is not going to execute for n times. See this p is less than or equal to n. It's not I less than or equal to n. So the condition is different. Then what is p? P is initially 0 and every time I is added to p. So now we don't know how many times it's going to execute. Let us analyze. I will take I value and b value. Initially this is 0 and this is 1. So what happens first time? This 1 is added and it becomes 1. The next time it will be 2, so it will be 1 plus 2, so it will be 3. The next time I will be 3 and this will be 1 plus 2 plus 3. Then I will be 4, it will be 1 plus 2 plus 3 plus 4, goes on. How many times it's going to execute? It's going to execute for k times. So what this will be? 1 plus 2 plus 3 plus 4 plus goes on to k time. Why I wrote k here? It's not reaching, it is not repeating for n times. Definitely it is repeating for some number of times that we don't know. We are sure that it will not execute for n times. Then how many times? Because the condition is different. So I said let it be k and let's find out that k. So if it is repeating for k times, then what is the condition? We assume that p has become greater than n. So when p became greater than n, it is stopping. We assume this. As long as p is less than or equal to n, it is repeating. So when p becomes greater than n, it is stopping. Right? Since p is what? See, it is k into k plus 1 by 2. P is k into k plus 1 by 2. So what's the condition? K into k plus 1 by 2 is greater than n. So when it will stop, when k into k plus 1 by 2 has become greater than n, it will stop. So what is k? Roughly we assume it as k square. So what is k? K is root n. K is root n. So this loop will execute for order of root n times. Let me show you quickly. I assigned 1. P is less than or equal to n, I plus plus. This is not I less than or equal to n. So we don't know how many times it's repeating. I is here, P is here. So I values are incrementing and every time I is added to P. So we don't know how many times. So let us say k times. And this will be 1 plus 2 plus 2 to k. Right? So that k is P is k into k plus 1 by 2 now. So we know that this will repeat as long as p is less than or equal to n. So it will stop when p becomes greater than n. So when p becomes greater than n, it will stop. So k into k plus 1 by 2 becomes greater than n, it will stop. So this is k square and k is root n. In the next video, you will find more examples, right? So different type of codes I will show you and I will show you how to analyze them. So this is how by tracing you can analyze them. So in the other video, this video also you can find few more algorithms with tracing. Next, I have this piece of code. I have to analyze and find the time complexity of this one. And this code also for loop is used. But loop is starting from 1 going up to n, that is less than n. And it is being multiplied by 2. I is multiplied by 2 every time. So blindly we cannot say this will execute for n times. We have to analyze this one. Let us see how many times this will execute. It's not n. We don't know how many times. Let us see. I will take the I value, initially this one. The next time it's going to be 1 into 2, that's 2. And next time it will be 2 into 2 again, so it will be 2 square. See, every time it's getting multiplied by 2. Then it's 2 square into 2 again, so this will be 2 power 3. Goes on. How many times? That we don't know. So let us say this will execute for 2 power k times. 2 power k times. Now, we know that this will terminate when I becomes greater than or equal to n. So we assume that when it has reached for some k number of times it has repeated, assume I became greater than or equal to n. And what's our I value? 2 power k. Since I is equals to 2 power k, therefore 2 power k has become greater than or equal to n. Now if I take 2 power k is equals to n, then k is how much? Log n base 2. Yes, this is the time complexity. So the statement will execute for order of